Machines don't just build products. They create art. They turn chaos into perfection, disorder into symmetry. And the best part? Watching them work is hypnotic. It's the kind of satisfaction you can't look away from. But how do these machines pull off these mechanical miracles? How do they transform raw materials into the objects we use every day? You're about to see the most satisfying, mind-blowing, and precision-driven factory processes on the planet. Ready? Let's go. Segment 1. Metal stamping and forging steel, iron and aluminum tough, unyielding, indestructible. At least, that's what we think. But inside metal stamping and forging factories, these mighty materials are molded, pressed, and reshaped as if they were nothing more than soft clay. Imagine a red-hot chunk of metal placed under a 50-ton press. The machine slams down with a force so intense it shakes the ground. In a single impact, that rough, formless slab transforms into a perfect component, ready for a car, a bridge, or even a spaceship. But the real magic? Watching molten metal poured into molds, glowing like lava, then cooled and solidified into flawless parts. It's brute force and delicate artistry, all in one. Segment 2, CNC machining. Precision beyond human hands, raw metal is tough. Shaping it with human hands? Imagine a solid block of aluminum, unassuming and dull. Now picture it placed inside a CNC machine. The cutting head moves at lightning speed, slicing through the metal like a knife through butter. The result? Perfectly sculpted components, gears, engine parts, even intricate aerospace components, all within micrometers of precision. The most mind-blowing part? These machines don't just cut, they drill, mill, and sculpt metal into shapes so intricate they look like they belong in a sci-fi movie. Now think about your smartphone, your laptop, even the chair you're sitting on. Somewhere, deep in a factory, a CNC machine played a role in making it. Precision isn't just a luxury, it's what keeps our world running. Segment 3. Injection molding. The birth of everyday objects. Plastic, one of the most used materials on Earth. But have you ever thought about how it's shaped? How a simple raw material becomes the toys we played with as kids, the cases of our gadgets, or even the very keyboard we type on? It all comes down to injection molding, one of the fastest, most efficient, and oddly satisfying manufacturing processes ever created. Here's how it works. Molten plastic, heated to extreme temperatures, is injected into a mold at high pressure. Within seconds, it cools, hardens, and pops out perfectly shaped, identical every single time. Imagine a machine churning out thousands of perfectly shaped plastic bottles in mere minutes, each one flawless. No mistakes, no imperfections, just efficiency at its peak. And it's not just about speed. The sheer variety is insane. Lego bricks, medical equipment, car interiors if it's made of plastic. Chances are it came from an injection molding machine. The best part? Watching it happen. The way the mold clamps shut, the liquid plastic fills every tiny space, and then like magic the mold opens, revealing a perfectly formed object. It's a loop of endless satisfaction. Segment 5. Textile weaving and knitting. Threads to fabric in seconds. Look around you. Your clothes, your curtains, your sofa all started as individual threads. But how do those thin strands become fabrics? Step inside a textile factory, and you'll see a sight that's both mesmerizing and almost unbelievable. Giant weaving machines move at lightning speed, pulling thousands of threads into place. no sewing, just instant formation of garments, like magic. It's speed, efficiency, and perfection in every stitch. Watching those needles move so fast they're almost a blur, that's the kind of factory satisfaction that never gets old. Segment 6, Paper Production from Pulp to Pages. Think about how often you use paper books, receipts, packaging. But how is it made? The process is something straight out of a science fiction movie. It starts with wood pulp, broken down into fibers, mixed with water, and spread onto a massive conveyor belt. Within minutes, that watery mess turns into a thin, uniform sheet. Then comes the most satisfying part, pressing and drying. Giant rollers squeeze out excess moisture, flattening the sheets to a perfect thickness. A final round of cutting and boom, it's paper. The sound of the machines, the rhythmic movement of the rollers, the continuous, endless flow of perfectly formed sheets. If you've never seen it before, it's the kind of thing you could watch for hours without even realizing it. Segment 7. Food Processing, the mesmerizing world of pasta production pasta. We all love it, but have you ever seen how it's made? It's a process so perfect, so rhythmic, that it feels more like an art form than manufacturing. Dough, soft and elastic, is pushed through massive extruders, forming the perfect shapes, spaghetti, pen, fusilli, all in an instant. Then a high-speed cutter slices the strands into the ideal length in the blink of an eye. What's even more satisfying? Watching pasta dry. Long racks of spaghetti hang in perfect alignment, drying at just the right temperature. No clumps, no uneven pieces, just pure perfection. And just like that, in mere minutes, a raw pile of ingredients transforms into the pasta that fills dinner plates around the world. Segment 8, Beverage Bottling. Precision at 1,000 bottles per minute. Ever grabbed a soda or water bottle and wondered, how do they fill millions of these so perfectly? The answer, insanely fast, ultra-precise bottling lines. Picture this, a river of empty bottles moving so fast your eyes can barely keep up. Then in a perfectly timed sequence, nozzles descend, psht. Each bottle fills to the exact level. No spills, no delays, just perfect precision every single time. Then comes the capper. In one seamless motion, caps are spun onto bottles at speeds that don't even seem possible. Within seconds, labels are applied, and the bottles are packed ready to hit store shelves worldwide. This is automation at its absolute best. The sheer efficiency, speed, and mechanical synchronization make it one of the most satisfying factory processes to watch. Segment 9. Brick Manufacturing. Turning clay into skyscraper foundations. Skyscrapers, roads, buildings. We see bricks everywhere, but few people know how they're made. It starts with raw clay, crushed and mixed into a thick paste. Then an extruder pushes out long slabs, cutting them into individual bricks with pinpoint accuracy. Next, the most fascinating part, the kiln firing. Inside massive ovens hotter than a volcano. Bricks bake at extreme temperatures, hardening into the durable blocks that hold up cities. And when they roll out, the perfect uniformity. Same size, same shape, every time. No wonder they've been used for thousands of years. Segment 10. Car Manufacturing. The Robotic Assembly Line. Symphony. Each movement is perfectly timed. Every part is assembled with millimeter accuracy. The most incredible part, the sheer speed and efficiency. A fully built car rolls off the production line every few minutes, ready to hit the road. Every modern vehicle you see was built this way, a mechanical ballet of power, precision, and engineering genius. Segment 11, Semiconductor Wafer Production. The microscopic world of precision. Every phone, every computer, every smart device you own runs on tiny chips. But have you ever stopped to think about how those chips are made? If you zoomed in on a microchip, you'd find billions of transistors working together in a pattern so complex, it looks more like a futuristic city than a piece of metal. But how do these chips come to life? It all starts with a silicon wafer, a thin, mirror-like disk that must be perfectly smooth and pure. Even the tiniest impurity could ruin an entire batch. From there, lasers and photolithography techniques etch microscopic circuits onto the wafer. This is where the magic happens. At a scale so small it defies human vision, patterns are created with absolute precision, shaping the pathways that allow electrical signals to flow. The final step? Cutting the wafer into individual chips, each no bigger than a fingernail but powerful enough to control an entire device. Once completed, these chips find their way into everything from smartphones to satellites, proving that some of the most fascinating factories in the world are working on a scale far too small for the naked eye to see. Segment 12. Bookbinding and printing. The art of mass production. There's something special about a freshly printed book. The crisp pages, the smell of ink, the smoothness of a brand new cover. But making a single book isn't a big deal, making millions of books without a single misprint. Now that's an art. It all starts with massive rolls of paper, sometimes bigger than a car, being fed into high-speed printing presses. These machines don't just print one page at a time, they print entire sheets filled with pages, perfectly aligned so that when they're folded and cut, they form a seamless book. And then comes the binding process, where stacks of pages are neatly arranged, their edges trimmed with laser precision, and a strong glue or stitching mechanism seals them together. It happens so fast you'd think it was all done by magic. Ever wondered how every book looks exactly the same? It's because these machines work with insane levels of consistency, ensuring no misplaced pages, no uneven bindings, just perfect books, one after another. And if you think this is satisfying, wait until you see the final step, the hardcover books getting their dust jackets. Each book slides through a machine, gets its cover neatly wrapped, and emerges as a finished product, ready for a reader's hands. Segment 13. Leather tanning and cutting. From rawhide to luxury, leather goods, whether it's a wallet, a jacket, or a car seat, carry an unmistakable touch of quality. But first, it goes through the tanning process, where chemicals and natural substances soften the hide. The hides are then dried and stretched until they reach the perfect consistency for cutting. Now, whether it's a bag's front panel, a car's leather seat cover, or the shape of a shoe, every piece is cut flawlessly, ensuring zero waste.
To the drying tunnel.
Finally, the next time you see a leather product, remember it wasn't just made. It was crafted by machines that have mastered the art of turning something raw into something refined. Segment 14. Recycling, sorting, and processing. Turning waste into treasure. We throw things away without a second thought. But what happens after your trash disappears? Some of it ends up in landfills, but thanks to modern technology, millions of tons of waste get a second life every year. Inside a recycling plant, conveyor belts move mountains of waste, while high-tech sorting systems work their magic. Lasers scan materials, magnets pull out metals, and air jets separate plastics all in a blink of an eye. Then comes the real transformation. Aluminum cans are melted into liquid metal, reshaped, and turned back into brand new cans. Plastic bottles are ground into tiny pellets, ready to be turned into everything from clothing to new containers. Old newspapers are pulped and reshaped into fresh sheets of paper. Which process amazed you the most? Let us know in the comments. If you love this video, hit that like button, share it with your friends, and don't forget to subscribe for more mind-blowing content. And of course, press the bell icon so you never miss an upload. See you in the next one.